In this short video, I will show you how wavetable synthesis works. Basically, a wavetable is derived from a sample, in other words, a digital recorded sound. Once recorded, the sample is divided or split into a various number of chunks, usually but not always of equal size, and each subsample or chunk of this main sample is then stored in a table where it can be accessed via a lookup number. This allows to select any part of the initial sound to be played back based on various inputs such as velocity or just using a feature that allows to access each of these subsamples individually. Let's take an example. Here I have a sample which has been converted into a wavetable, in other words, has been split into successive subsamples which have been stored in a table. Let's listen to the original audio sample. As you could hear, this sample is a basic sound with a rapidly increasing pitch. Note that here the original sound has been split into 10 chunks, but Pigments allows up to 256 splits for a given audio sample. Here I'm playing the first sample, then the second one, the third one, etc. So I could play individually each subsample. In Pigments, that can easily be done by using this position button here. An interesting option is to morph the subsample so that we can smoothly migrate from one sample to the next. Listen. And now, if I use a modulation source to drive this position button here, I can get more interesting results, in particular using the filters and the effects to smooth the transitions. Check the blue dot here to see the modulation selected in the lookup table. Finally, I'd like to talk about a specific feature called wavefolding. Let's switch to a 2D view of the signal and use the folding feature. As you can see graphically, here wavefolding consists in, well, folding the signal back onto itself. In other words, when you increase the level of the fold button, instead of increasing the signal and get saturation distortion, the signal mirrors itself and therefore adds more harmonics. In Pigments, you can even define the shapes of the mirroring effect. This effect is even more dramatic when using the unison feature, which basically adds slightly detuned voice to your sounds. This can add interesting modulation to the signal. Listen. And these effects are even more interesting when you combine them and play chords.